open loop configuration, another one is closed loop configuration. So the term open loop indicates nothing but there will be no feedback in any form, so which is taken from the output to the input, and so when connected in open loop configuration, the op amp will act as a high gain amplifier. Why? Because the gain is very high in open loop configuration. And similarly, the term closed loop configuration implies nothing but it uses a feedback, that is the input is fed a small portion of output, so which refers to feedback. In this, the gain is controlled and the op amp can be worked linearly region. So op amp can be worked in linear region. So this is how the op amp is used in two configuration. So let us go for open loop configuration. So in open loop configuration, there is no feedback. So the op amp can work in three modes. Okay, that is differential amplifier, inverting amplifier, and non-inverting amplifier. So in open loop configuration, the op amp can work in three modes, that is differential amplifier, inverting amplifier, and non-inverting amplifier. So let us see the differential amplifier. So this is the differential amplifier circuit where in differential amplifier, the op amp amplifies the difference of the two input signals. The op amp amplifies the difference of the two input signals. Here we are giving input signal Vi1 to non-inverting terminal and Vi2 to inverting terminal. Vi1 is to non-inverting terminal and Vi2 is the inverting terminal. So that means we are giving two inputs. Then the output should be the difference of the two inputs, which is amplifier 1. The output should be a difference of the two inputs, which is nothing but a amplifier 1. So here we have internal resistance R1, Ri1, and for second signal Ri2. Since the internal resistance are somewhat very less when compared to that of the things, and therefore, so here, so Vi1 is the input to the non-inverting terminal, and Vi2 is the input to the inverting terminal, and the difference is nothing but Vid. The difference of the two things is nothing but Vid. Therefore, the output will be equal to the gain of the amplifier into Vid. The gain of the amplifier into Vid. So where A gain, gain A is equal to, output by input. So output is nothing but, so difference of the two inputs Vid by, so sorry, V naught by Vid. So V naught by Vid gain. So output is V naught and the input nothing but difference of the two inputs of Vid. So what is Vid? Vid is nothing but Vi1 minus Vi2. Vid implies nothing but Vi1 minus Vi2, and therefore we got the output as this one, that is V naught is equal to gain of the amplifier into V1 minus V2, which is nothing but the difference of the two inputs. Okay, here there is no feedback is taken, there is no feedback here, so that means the output is not connected to input in any form, and that is why it is nothing but open loop configuration. That is what is nothing but a open loop configuration. So this is a difference amplifier or differential amplifier. So that means that it amplifies the difference of the two input signals. So the input signals here are nothing but Vi1 and Vi2, and the difference is nothing but Vi1 minus Vi2 is the difference of the two inputs, which is otherwise called as Vid, and therefore output is equal to V naught is equal to A into Vid, where Vid is nothing but Vi1 minus Vi2. So this is the in differential mode. Now we will see in this mode is nothing but inverting or non-inverting. It is inverting mode. So inverting mode, so what is the thing is that the input is given to the inverting terminal. The input is given to the inverting terminal, that is minus terminal. And the non-inverting terminal is connected to the ground. The non-inverting terminal is connected to the ground. So therefore, the plus is at 0 and the minus, the inverting terminal is at voltage Vi. But we know that the op amp is the one which amplifies the difference of the two input signals. So therefore, so we have the output V naught is equal to A into V1 Vi1. Take it as Vi1 minus Vi2. Vi1 minus Vi2. So here, so Vi1 is taken as 0 Vi1 is taken at 0, but Vi2 is nothing but Vi. So this is Vi2, Vi2 is nothing but Vi. So that is nothing but A times. So Vi1 is 0, and what is Vi2? And Vi2 is nothing but Vi. Vi2 is nothing but Vi. So therefore what will happens? So this is equal to minus of A into Vi. So therefore output is nothing but minus of A into Va. Therefore the input and output has a phase shift of 180 degrees. Why? Because it has a negative sign. It has a negative sign, and therefore it is called as an inverting amplifier. Therefore it is called as an inverting amplifier. So that means that in inverting amplifier, the input is given to the inverting terminal, and the non-inverting terminal is connected to the ground. So that means that we are not giving any input to the non-inverting terminal. So just we are giving only the input to the inverting terminal, and therefore output is nothing but the difference of the two inputs. Anyway, one of the input is 0, and therefore the other input is nothing but minus Vi. So therefore the output is nothing but V0 is equal to minus A into Va. So this is for inverting amplifier, and similarly for non-inverting amplifier. Similarly for non-inverting amplifier. So here the input is given to the non-inverting terminal, and the inverting terminal is connected to the ground, and the inverting terminal is connected to the ground, and we know that V0 is equal to A into Vi1 minus Vi2. Vi1 minus Vi2. So here, so what is Vi1? So Vi1 is nothing but Vi. Vi1 is nothing but Vi. So Vi1 is equal to Vi. And similarly, so what about Vi2? This is Vi2. So Vi2 is equal to what? 0. So we are not giving to any input to the inverting terminal. So therefore, substituting the values here, so Vi1 is nothing but Vi, and Vi2 is 0, and therefore we have V0 is equal to A into Va. V0 is equal to A into Va. So this is what we got here. V0 is equal to A into Va. That means that the output is in same phase with that of the input. So that means that if the input signal is like this, imply nothing but the output signal also like the same way, but it is a amplified one. But it is a amplified one. So so the input and output will have the same phase. Why? Because here there is no minus signal, so you have only the plus. Therefore, it is referred to as a non-inverting amplifier. So non-inverting amplifier. So the input is not inverted at the output side. The input is not inverted at the output side. That is what is called as non-inverting amplifier. So, so we have three configuration in closed loop configuration. One is differential amplifier. Here, differential amplifier is the one which the op amp amplifies the difference of the two input signals, and therefore V0 is equal to Vi1 minus Vi2, the two signals. Similarly, in inverting amplifier, the input is given to the inverting terminal, and the non-inverting terminal is given to the ground, and therefore output is nothing but a inverting of the input. The output is a inverting of the input. For suppose if this is the signal, if this is a signal, and the output will be in the reverse manner. The output will be amplified of the reverse manner. So why? Because so input and output will have a 180 degrees phase shift. Input and output will have a 180 degrees phase shift. Okay, so this is the case, and where in case of non-inverting amplifier, the input is so where in case of non-inverting amplifier, the input is in same phase with that of the output. Okay, or the output is in same phase with that of the input. So that means that so it amplifies the input signal without changing its phase. Okay, in this the input is given to the non-inverting terminal, and the inverting terminal is given to the ground. The inverting terminal is given to the ground. So therefore we have V0 is equal to A into Va. So this is the three configuration that we can see in the open loop configuration. So this open loop configuration cannot be used. It has some defects. So the open loop configuration cannot be used in linear mode. Cannot be used in linear mode. Why? Because since the gain of the open loop configuration is very high, the gain of the open loop configuration is very high, which is approximately infinity. Okay, that means that if at all any small voltage, if at all there is any small voltage that is present at the input, is get amplified, and the output will get into saturation immediately. The output will get into saturation immediately. So saturation implies nothing but we have plus VCC and minus VCC. You know that you have plus VCC and we have minus VCC. That is minus VEE. So this plus VCC is approximately equal to 15 volts and this minus V is approximately equal to minus 15 volts. So therefore there is a voltage swing of how much volts it is there? Plus 15, this is plus 15 and this minus 15. A voltage by swing of 30 volts. We have a voltage swing of 30 volts. That means the op amp get into saturation implies nothing but this plus 15 volts is equal to plus V set. So that means that the output amp will not go beyond plus V set. The output of the op amp will not go beyond plus V set. And similarly, it won't go beyond minus V set. It won't go beyond minus V set. That means that the op amp always swings between plus V set and minus V set. The op amp always swings between plus V set and minus V set. Okay. So for example, okay, so that means the op amp will have plus VCC and minus VEE. So which is the extreme output voltages. These are nothing but the extreme output voltage. That means that the op amp may not go beyond plus VSAT and minus VSAT. So that means that if at all, so for example, here we're giving an input here. So input is to the plus. So that means that the output immediately goes to plus VSAT. The output will immediately goes to plus VSAT. So in case of minus VSAT, in case of my inverting terminal, inverting amplifier, the output will goes to minus VSAT immediately. The output will goes to minus VSAT. Why? Because it has more gain. Why? Because it has the gain is very high. The gain is very high. So for example, if this is the input, for example, if this is the input, the output will be since it is plus. So up to plus. So when it is small voltage which increases plus, the output will goes to plus V set. Now the input is going to minus, that is zero below zero. So automatically what will happen? The output will goes to minus V set. So like that, this is the two things. That is plus V set, and this is minus V set. So that means that the output always switch between plus V set and minus V set in case of open loop configuration. So that means that we will get only two values, that is either plus V set or minus V set. So therefore, this open loop configuration cannot be used for linear operations. Cannot be used for linear operations. So linear operations imply nothing but if the input changes, the output also changes with respect to the input. The output should also changes with respect to the input. So in the open loop configuration, it cannot be possible. In open loop configuration, it cannot be possible. Why? Because it can produce only two types of output, either it is plus VSAT or minus VSAT. And that is why in most of the cases, this open loop configuration is not used. This open loop configuration is not used. Only in special cases only we are going for open loop configuration. Okay. So that is the problem of open loop configuration. Okay, so in order to have that in detail, so let us think that this is the voltage transfer characteristics. This is the voltage transfer characteristics of a op amp. This is the open loop configuration. That means that if at all a small voltage is there, either it plus or a minus. So if it is slightly greater than plus, then immediately the output goes to plus V set. The immediately output goes to plus V set. And if at all the difference of the two input signals is minus, it will immediately goes to minus V set. Okay, so that means that the range of A and B, the range of A and B is very small. So which will be in the order of some microvolts, which will be in the order of some microvolts. So that means that the op amp can work as linearly in this range only, that is A to B range. So which is in the order of microvolts only. That is, if the input is some microvolts, so which is in the range between A and B, then only the op amp will work in linear manner. Okay, which is not at all used in many of the applications, and that is why, this op amp is mostly used in closed loop amp or configuration. That is why this op amp mainly used in closed loop configuration for linear operations, and therefore what will happen in closed loop configuration, the gain is controlled. And it can be operated in the linear range. The op amp can be operated in the linear range. Okay, and that is why we go for closed loop configuration for linear operations. So if you want for non-linear operations, then we can go for open loop configuration. Okay, so the concept of this one is about voltage transfer characteristics. So this is the input voltage and this is the output voltage. So VD is nothing but the difference of the two input voltages. Okay, so if the difference of the two input voltages, if VD is slightly plus, then the output will goes to plus V set. If the VD, the difference of the two input voltage, is slightly minus, then output will goes to minus V set. So immediately, so the range of A to B will be in the order of microvolts only, where it cannot be possible in practically. And therefore, in order to control this gain, so what we are doing is nothing but we are using a feedback. So we know that we have two types of feedbacks. One is positive feedback, another one is negative feedback. And we have studied about the negative feedback properties. So in negative feedback amplifier, in negative feedback, what is the general characteristics? Nothing but the first thing is nothing but it reduces the gain. That is, gain is controlled. So when the gain is controlled, automatically what will happen? The bandwidth increases, and almost all the input impedance increases, the output impedance decreases. Okay, we have the characteristics we have studied in the unit 2, the feedback amplifiers. Okay, so here we are supposed used to operate the op amp in the negative feedback. Why? Because it controls the gain, and it cannot exceeds the output of the op amp to get into saturation. It won't allow the output to get into saturation. Okay, so by controlling, so with the help of a negative feedback, and that is why we'll go for closed loop configuration. So this is the problem of open loop configuration. Okay, so that means next we'll go to the coming to the closed loop configuration. So in closed loop configuration, the op amp uses a feedback. So generally we use a negative feedback. So by using the negative feedback, what will happens? The op amp linearity will be increases greatly. So we have the negative feedback. We can control the gain. So which drives the op amp out of its linear range. Okay. And here the gain that is obtained by using a closed loop is nothing but the closed loop gain. The gain resulting with the feedback is nothing but a closed loop gain. So let us see the two configurations. One is inverting amplifier and other one is non-inverting amplifier. So inverting amplifier imply nothing but the input is given to the inverting terminal. The input is given to the inverting terminal. The non-inverting terminal is given to the ground. So keep in mind, according to the minus and plus only, we are applying the input. According to the minus and plus only we are applying the input. So minus imply nothing but inverting terminal, plus imply nothing but non-inverting terminal. Okay, so keep in mind this is very important. This is very important. Here the case we have mentioned the plus on the top and the minus at the bottom. Plus at the top and minus at the bottom, and here we are putting minus at the top and plus at the bottom. So whatever may be the symbols, whatever may be the interchange of symbols, we have to apply according to that of the concept. We have to apply according to that of the concept. For example, here if you make this is minus and this is plus. For example, we are making this is minus and this is plus. So automatically what will happen? This minus has to be given to the ground and the plus has to be given to the input. The plus has to be given input to input. That is according to the symbol that is there inside the triangle, the symbol. Okay, so according to that only we have to apply the input. According to only to apply the input. So not blindly. You should not think blindly. Okay, you should not think blindly. You have to think concept wise. You have to think concept wise. So what we have done is nothing but we are putting minus top and plus bottom, and here we have plus top and minus bottom, plus top and minus bottom. So if you want to interchange means automatically the input that is applying should also be interchanged. The input should also be applied to the interchange. You have to interchange the inputs also. The similar manner here is the case. Here, since it is an inverting amplifier, we are applying input to the inverting terminal. We are applying input to the inverting terminal, and automatically the non-inverting terminal is given to the ground. The non-inverting terminal is given to the ground. So that is the concept. Okay, so you have to keep in mind that the symbols are the most important. That is inside the triangle. That is inside the triangle. If you make it is plus, and if you take minus and you apply the input to the plus imply nothing but the inverting terminal concept will goes wrong. The inverting terminal concept will goes wrong. That means that you get 0 marks. You get 0 marks, and that is why most of the people are supposed to fail in this subject. Okay, only because of plus and minus only. Only because of plus and minus. If you simply interchange the plus and minus, and if you not apply the input as per the concept imply nothing but the entire concept is wrong. Whatever you have written, everything will gets wrong. So that is why keep in mind that the plus and minus should be very careful. Plus and minus should be very careful. Since it is inverting amplifier, so therefore the input is given to the inverting terminal. Hello. So the input is going to the inverting terminal and the non-inverting terminal is going to the ground. That means that it is a inverting amplifier. So since it is closed loop configuration, the output is connected to the input via a feedback network, that is RF. So RF is nothing but the feedback resistance, and the output is connected to the inverting terminal here. The output is connected to the inverting terminal. That means that the output and input has a phase shift of 180 degrees. The output of an input has a phase shift of 180 degrees, and therefore it is referred to nothing but a negative feedback. Therefore, it is nothing but a negative feedback. So why? Because the input is having a positive feedback and the output as a negative one, and the same negative is given to that of the a positive input. Same negative is given to that of the positive input, and therefore it is nothing but a negative feedback. Therefore, it is nothing but a negative feedback. Okay, so that is why the gain is controlled here. The gain is controlled here, and according to the input, the output varies. According to the input, the output varies. Okay, so that is the thing here. Similarly, for non-inverting amplifier, so the input is given to the non-inverting terminal, and the inverting terminal is given to the ground, and the inverting terminal is given to the ground. So that is ground. So that means that this concept is nothing but a non-inverting amplifier. And here also, so what the thing is nothing but the output will have a positive phase, and we are giving this positive phase to that of the negative terminal of the op amp. We are giving the positive phase to the negative terminal of the op amp, so in which the op amp converts the positive phase to the negative phase in the inside the op amp, and therefore it becomes a negative feedback. Therefore it becomes a negative feedback. So that means that, so in both the cases it uses a negative feedback. Both the cases it uses a negative feedback. So that is nothing but the closed loop and open loop configuration. Closed loop and open loop configuration. You have to keep in mind that this minus and plus plays an important role. Plays an important role. Okay. So we have to go in detail about the closed loop configuration in coming class. So how we have to reduce this equation and how to find the gain of the closed loop amplifier and both the cases, inverting amplifier and non-inverting amplifier, and as well as in the differential amplifier. So for a basic understanding only, I have put this here. Okay. And in sometimes in special cases, you can connect the op amp to the positive terminal. You can connect the feedback to the positive terminal, which becomes a positive feedback. Which becomes a positive feedback. If the output is connected to direct to the positive terminal of the op amp, then it becomes a positive feedback. Okay. So in this manner, so we can have the closed loop configuration and open loop configuration. So coming to the op amp assumptions, the realistic assumptions. This is the main important. You have to keep in mind always about the op amp. When you think about the op amp, you have to keep this thing into mind always. Into mind always. The first point is nothing but the op amp doesn't draw any current. The op amp doesn't draw any current at both the input terminals. At both the input terminals. Okay, doesn't draw any current. That is no current at the input terminal. That is I1 is equal to I2 is equal to 0. For example, so take the differential amplifier. So take the differential amplifier. The current that is due to the V1. The current that is due to the V1 is nothing but I1. And current that is due to the V2 is nothing but I2. And that means that the op amp is not allowed any current to pass through it. The op amp doesn't allow any current to pass through it. So that means that it is upsetting the flow of current into the op amp. It upsetting the flow of current into the op amp. So that is I1 is equal to 0 at input side and I2 is equal to 0 at the input side. So that means that it doesn't draw any current. It doesn't draw any current imply nothing but its input impedance. Its input impedance is very high. Its impedance is very high. And that is why we can see the equivalent circuit. So what the equivalent circuit will have a high resistance here. So in which it is connected to the both the input terminals. In which it is connected to the both the input terminals, which resembles nothing but, so it doesn't allow any current to flow through it. It doesn't allow any current to flow through it. So that is why its input impedance is very, very high. Its input impedance is very, very high. So that is the first assumption that we have to keep in mind. That is, so that is the op amp doesn't draw any current at the input terminal, that is either at inverting terminal or non-inverting terminal. Either at inverting terminal or non-inverting terminal. Since the input impedance is very high, we can drive any source. We can drive any source and there will be no loading on the driver side. And there will be no loading on the driver stage. So we can drive any load, any source. That is, we can drive a DC source, you can drive a AC source, you can give a mixture of AC source and DC source as well. So whatever may be, it can accept and it doesn't have any load on the driver side. So that is the first assumption. And second one is nothing but, we know that the gain of the ideal op amp is infinite. And therefore, the differential input should be essentially zero for finite output voltage. That is, Vd is equal to V1 minus V2 should be equal to 0. V1 minus V2 should be equal to 0. That means that whenever there is no input, the output should also 0. The output should also 0. So if any one of the input side is also any difference, the output will get into saturation. The output will get into saturation, and that is why the gain of, since the gain of the op amp is infinite, therefore the VD must be equal to 0. That is, differential input voltage must be equal to 0 for finite output. For finite output. So that is what we have to keep in mind. So VD nothing but V1 minus V. That is two inputs. The difference of the two inputs should be equal to 0 for finite output. That is the second case. And the output voltage is independent of the current drawn from the output terminals. The output voltage is independent of the current drawn from the output terminals, and therefore its output impedance is 0. Its output impedance is 0. So let us see the equivalent circuit here. Let us see the output equivalent circuit here. Here the output is independent of the current drawn. Independent of the current. So there is no current that is drawn at the output side. There is no current that is drawn at the output side, and therefore its output impedance is 0. Its output impedance is 0. Okay, and that is why it can drive n number of circuits. It can drive n number of circuits. N number of circuits is nothing but infinite number of other circuits. So that means that the output of op amp can be connected to a amplifier or in a small circuit or any other circuits or any other circuits. Why? Because it doesn't have any load on the output side. It doesn't have any load on the output side. Why? Because the output voltage is independent of the current drawn from the output terminals. It is independent of the current drawn from the output terminals. So these are the three assumptions that we have to keep in mind. So the op amp doesn't draw any current. So that is I1 is equal to I2 is equal to 0. The differential voltage, that the differential voltage should be 0. That is V1 minus V2, which is nothing but VD, should be equal to 0 for finite output. And the output is the independent of the current drawn from the output terminals, and therefore the output impedance is 0, and therefore it can drive an infinite number of circuits. Therefore it can drive an infinite number of other circuits. Okay, and this constitutes nothing but the ideal op amp realistic assumptions. So you have to keep in mind. You have to keep in mind all these 3 points. You have to keep in mind all these 3 points forever when you consider about a op amp. When you consider about the op amp. So enough for today. We have seen today about the open loop configuration and closed loop. Why you go for closed loop configuration? Why you go for closed loop configuration? So for linear operations, we have to go for closed loop configuration. For non-linear operations, you can go for open loop configuration. In open loop configuration, the only possible output is nothing but either plus Vset or minus Vset. Either plus Vset or minus Vset. In closed loop configuration, the output will be linear with respect to the input by introducing a feedback. So which is nothing but a negative feedback. Almost it uses a negative feedback. Okay, so